So we have talked about hypothesis testing, and we're going to start moving into doing more specific hypothesis tests, but there's just a few more topics that we need to wrap up first. So I'm going to use this example. It's by a researcher named Matt Model, and he ran a study in 2010. He got 2,000 participants, and he wanted to see if people who were politically moderate were able to perceive shades of gray more accurately than people who were on the far left or the far right. So literally, he had them looking at the color black, the color white, and then shades of gray in between. And his hypothesis was that, kind of the null hypothesis, moderates can't see gray better than extremists. And his alternative hypothesis was that moderates can see gray better. And he was able to do this study. He found a p-value, and his p-value was 0.01. And so if we had an alpha level of 0.05, 0.01 is less than 0.05, he was able to reject the null, and he had evidence in support of the idea that moderates could see gray better. That's like very headline worthy, right? That your political opinions actually have an impact on the way that you can physically see the world. But because it was such a big conclusion, he decided he was going to rerun the study. So he got some more participants, he did the study again, and this time the p-value was 0.059. So if alpha is 0.05, 0.59 is not less than 0.05, and so he could not reject the null hypothesis. And the question is, what happened here? So one version of the study showed a lot of significance, a lot of evidence against the null, and the other one did not show any evidence against the null. And there's a lot of things that could have been going on in this example. One of them has to do with errors. So in statistics, we have two types of errors that we think about in terms of hypothesis testing. One is a type 1 error, that's rejecting a true null, and the other one is a type 2 error, and that's when you don't reject a false null. And this is in the category of statisticians should not be allowed to name things. I feel like type 1 and type 2 error are very hard to remember, and don't really have any meaning, but they are commonly used terms, so we have to try to remember. They could also be called a false positive and a false negative. And so one mnemonic device that I have heard is that if you look at type 1, that 1 kind of looks like a P. So this is a false positive. And I'll try and draw that P on here. There's the P on top of the I. And then the other one, the type 2, that's a false negative. And that's because the 2 kind of looks like an N. Again, I'm going to try and draw it on here for you. So it kind of looks like an N. There's other mnemonic devices out there. There's one about the boy who cried wolf. First, he's doing a false positive. He's saying there's a wolf when there's not actually. And then at the end, it's a false negative. There is a wolf, but no one believes him. But I think if you're just getting started, it's probably something that you'd want to write on your one-page note sheet. A type 1 error is when you reject a true null, and a type 2 error is when you don't reject a false null. So there's this analogy to law in the US legal system. The goal of our legal system is that a person is innocent until they're proven guilty, and the evidence of guilt has to be beyond a shadow of a doubt. And so this is like saying our null hypothesis is not guilty and our alternative hypothesis is guilty. And in order to reject the null hypothesis and say that that we don't have evidence that they are not guilty, we need to be beyond a shadow of a doubt. And then we can make two types of mistakes. One is a false positive, again, positive, and my mnemonic is type 1, and that 1 somehow kind of looks like a P. And that would be that we convict an innocent person. So we say that we're going to reject the null and say that the person is guilty, even though they were actually innocent. And the other kind of mistake that we could make is a type 2 error where we release a guilty person. And this is a false negative. Negative. And again, I'll write out my kind of mnemonic device and try and draw that N on there so that you can hopefully see it. So a type 2 error. You're always going to be at risk of making either of these types of errors. That's kind of the problem with law and also with hypothesis testing, is sometimes you're probably going to convict an innocent person and sometimes you're going to release a guilty person. But as the researcher or as the judge, you get to decide which one of those types of error is worse. Is it worse to convict an innocent person, or is it worse to release a guilty person? And maybe we can talk about that in synchronous class. I don't think there's a correct answer. I think people have different opinions there. And again, that's what makes these sorts of things really hard. So that extremists and black and white, there's kind of two things that could have happened. One is the original study with that small p-value made a type 1 error, and the null hypothesis was really true. So even though they rejected the null was really true. The other option would be that second study, the follow-up with the big p-value, where they failed to reject the null, it made a type 2 error, and the alternative is really true. There's also the possibility that there were no errors made and just different studies found different things. Maybe something just happened randomly. Let's just think about the probability of making these kinds of errors. So let's think about this plot, and I want to consider an alpha of 0.05. So I've got 1,000 samples in this randomization dot plot. I guess you probably can't see that up in the corner, but my samples is equal to 1,000. So an alpha of 0.05, it's going to be the proportion that's as extreme or more extreme, the proportion, and it needs to come out to be 0.05. It's something out of 1,000, so it's going to be 50 out of 1,000 to be 0.05. So we could kind of count, and this might be kind of tedious, but we could count into about 50. 1, 2, 3, 4, 5. Okay, so it's right about here. So it looks like, oh, I kind of lost my track, but it's right about here. So this area would be about 0.05. But this randomization dot plot, these are all things that actually happened when the null was true. The things out in the tails, they were very rare, but they actually did happen. So by setting our alpha level of 0.05, we're saying that in all of these times, we're going to be making a type 1 error. But if we set that 0.05, we're just saying we're willing to make an error in that direction 5% of the time. Versus if we were going to try to do an alpha equal to 0.01, and let's see, that's going to be something out of 1,000. It's going to be 10 out of 1,000. And again, I could just count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think it was right here. So that would be my p-value. And again, these things we actually observed under the null hypothesis. So even though they happened under the null hypothesis, we would say we're going to reject the null if we were out in this tail. So we're going to make a mistake some percent of the time. And that means that the probability of making a type 1 error, rejecting a true null, is the same as the significance level, alpha. So if you have alpha equal to 0.05, you're going to make a type 1 error 5% of the time.